Good morning, dear students. Today we are going to discuss about some numericals on the DC generators. So let us to take a numerical. This one, a shunt generator delivers 450 ampere at 230 voltage, and the resistance of the shunt field and armature are 50 ohms and 0.03 ohms respectively. That means shunt field resistance 50 ohm and armature resistance is 0.03 ohms. So we have to calculate the generated EMF generator. So in a shunt generator means what? A generator, a DC generator in which the field is connected parallel to the armature, right? Field is connected to the parallel to armature. So this is the representation of the DC shunt generator. So EG is nothing but the voltage developed in the armature, right? So it will supply a current of armature current. This armature current, outgoing current, which is divided into two portions. एक तो आपको load current, another one is the shunt current. Shunt field current flow through the shunt field, and the load current or I, which is flow to your load. So they have given the terminal voltage across the load terminal 230 voltage, and armature current is not given, shunt field current is not given, right? And this is the load current is given 450 ampere, and they are asking to calculate the generated EMF. So when you consider the generated EMF, so that can be calculated in two ways, right? One is the EMF equation of the generator is what? Eg equal to Zn pi divided by 60 into P by A, where Z is nothing but the number of conductors, and N is nothing but the speed, and pi is nothing but flux, and this is 60 constant, and P is number of pole, and A is nothing but number of parallel path. So these equations here we cannot use because there is no information about the speed, there is no information about the number of conductor, there is no information about the number of poles and parallel path. Then what we can use? Here we can use the EMF equation or voltage equation from the diagram. From this diagram you can say the EMF generated in the generator is nothing but the EG equal to the voltage drop in your armature plus the voltage available at the terminal. So that's what the equation is written. This is called as a voltage equation of the DC generator. EG equal to V plus voltage drop in armature. So V is given, right? V is given for us. That is nothing but your 230 voltage. But the value of drop in armature is not given. So we have to calculate the voltage drop in armature. How we can calculate voltage drop in armature? Voltage drop in armature is nothing but the V voltage drop in the armature is nothing but the voltage current flow through the armature winding IA multiplied by the armature resistance. So armature resistance given 0.03 ampere, but your armature current is not given. So we have to determine the armature current. So what does armature current? From the diagram, you can say armature current is nothing but IA equal to, you can apply the Kirchhoff's current law here. IA equal to I plus ISH. IA equal to I plus ISH. So from that, I is given, but ISH is not given. So ISH, how we will determine? ISH we can determine it's nothing but the voltage across the shunt field winding divided by the resistance of the shunt field. So आपको you can determine the ISH. ISH nothing but voltage across the terminal 230 voltage divided by the resistance of the shunt field, that is 50 ohm. So that is what here I have determined the shunt current, shunt field current equal to 230 voltage by 50. It is nothing but the 4.6 ampere. So now you can easily determine IA. IA is nothing but I plus ISH. So I is already given 450 ampere, and ISH we determine by nothing but the voltage across your field winding. This is 230 voltage divided by the field wind resistance to 50 ohm. So आपका हो गया. Then it is getting 230 by 50 equal to 4.6 ampere. So now IA equal to what? IA is determined. IA equal to I plus ISH. So I is given data 450 ampere, and ISH we determined 4.6 ampere. So IA equal to 454.6 ampere. Now we have to calculate to only voltage drop according to this equation because we need EG. So V is already available. Voltage drop in armature, that is nothing but armature current multiply with the armature resistance. So armature current is nothing but 454.6 multiplied by 0.03. 0.03 is nothing but your armature resistance. You got the 13.6 voltage. So now you can say the generated EMF is equal to terminal voltage plus armature drop. Terminal voltage is given 230 voltage and armature drop is 13.6 volt. So you get the total generated voltage 243.6 volt. 243.6 volt. This is what the solution for this numerical. A shunt generator delivers 450 ampere at 230 voltage. The resistance of the shunt field and armature or the 50 ohm and 0.03 ohm respectively. So calculate this EMF generator. So we have used the EMF generator equation, that is EMF equation of the generator is equal to V plus voltage drop in armature. To voltage drop V is given to V is given your 230 voltage and we have not given the voltage drop in armature. So to determine the voltage drop in armature, it is nothing but the product of armature current and armature resistance. So armature current is given but armature current is not given but armature resistance given. So to determine the armature current, we apply here Kirchhoff's voltage law where IA equal to I plus ISH. So, and again IEA, to determine IA, I is given but ISH is not given. So ISH is nothing but the voltage across shunt field, which is nothing but 230 divided by field resistance 50. So you get the ISH. So then you get the IA equal to I plus ISH. I plus ISH, you got it from here. Right, I plus ISH, then armature voltage drop, IA into RA, IA is from this and RA already given 0.0, so you got the armature voltage drop and now the generated EMF equal to terminal voltage 230 given and armature calculated from here, armature drop is calculated from here to supply, that's right. This is one numerical to determine the EMF generated in the shunt generator, right. The next one, let us to have another numerical where a 4-pole generator having wave wound armature winding has 51 slots and each slot contains 20 conductors. What will be the voltage generated in the machine when the machine is driven at the speed of the 1500 RPM? Assume that flux per pole is 7 milliweber. So this data is given for us where the number of poles given and conductors also given, and also we have been given about the speed and we have also given about the flux. So in this case, to determine the generator voltage, we can use this formula Eg equal to Zn pi divided by 60 P by A, where Z is nothing but the number of conductors. So number of conductors they have not directly given, they given the number of slots and each slot contain 20 conductors. So we have to determine the total number of conductors, nothing but the number of slots multiplied by the number of conductors in each slot. So we have taken Z is nothing but 51 into 20 multiplied by N is nothing but RPM speed 1500 substituted and the flux per pole is nothing but the 7 milliweber. So 7 into 10 to the power minus 3 we have to do, right, and divided by 60 and P is nothing but number of pole which is given 4 and A is nothing but number of parallel path. The parallel path is depending upon the type of winding. So for wave winding it is A equal to 2 and for lap winding it is A equal to P. This is the standard one where based on the which type of winding is used. There are two type of winding can be used, right, wave winding and lap winding. In case of wave winding it is A equal to 2, in case of lap winding it is A equal to P. So we have given it is a wave winding. So wave winding means A equal to 2. So we substitute the A equal to 2 and solve this one. We get this generated EMF 178.5 volt. So this is a simple numerical, right, for the EMF generator. Let us to have another one more numerical where a 200 volt DC short shunt generator is supplied a load current of 15 ampere. So short shunt generator. Short shunt generator means you can say like this. The shunt field is connected to across your armature. Long shunt means the shunt field will be connected across your armature plus series field winding, right? So but this shunt short shunt they have said. So short shunt means the shunt field winding of the compound generator is connected to this generator armature. This is called as a short shunt, right? So this data is short shunt case. We have short shunt generator is applied a load current of 15 ampere load current is been supplied. The armature resistance is 0.5 ohm and the series field resistance is 0.5 ohm and the shunt field resistance is 100 ohm. So we have to calculate the EMF generated and also given the brush drop. The brush drop is we know that the carbon brush and commutators arrangement is for the purpose of to converting the AC into DC in the DC generator, right? So when if they have given the brush drop, then we have to consider that also, right, for the EMF equation. So here we have to use the EMF equation again. EG equal to the total voltage plus drop in armature plus drop in field winding, because this is nothing but the series field winding. So the compound machine. So series field winding loss also we have to consider. That is why here we have written this armature drop plus series field winding drop plus brush drop. Brush drop is only we will be considering if it is given. Not given, then we need not to bother about it, right? So we have to now calculate the EMF equation. That we have to calculate the EG where the V is given and IARA is not given, the armature drop is not given, and this series drop also not given. So series drop is nothing but the voltage drop in the series field winding. So series field winding, which current is flowing? Load current is flowing. So load current, and you can multiply with your shunt series field resistance. You will get the series drop. Right? The series drop can be simply determined from this given value. IL is given. Yes, IL is given. You can see the generator load current of 15 ampere. Load current is same. Load current or series field current, both are same. Same current is flowing. So you multiply the load current with your series field resistance to get the series drop. This one, IL or SC. And brush drop is given, right? So IL and or SC we have calculated from this voltage drop in the series winding. Yes, we have calculated here. Voltage drop in the series winding, 200 terminal voltage plus the drop in the series field winding. Drop in the series field winding is nothing but IL into RSC. So IL is 15 and RSC 0.5. So you get the 7.5. So total series drop, we have to consider the total entire drop. So the terminal voltage is given plus the drop in the series. That is nothing but your voltage across the series winding. So 200 plus 7.5 is nothing but your series winding drop. Right. So what the total voltage total is nothing but your 200 plus 7.5, 207.5, right? Then we have to determine the armature drop. So armature drop is nothing but the product of armature current and armature resistance. So armature current, how we determine armature current? You can see this armature current is coming out of this armature. So you can say armature current is nothing but shunt field current plus load current, right? Armature current is nothing but shunt field current plus load current. So shunt field current you have given. No, shunt field current is not given, but you can calculate it because shunt field resistance is given and the total voltage available in the total voltage also given. So total voltage here, total voltage across your machine, total voltage across here is nothing but you have calculated total voltage here. Where? See, 200 plus 7.5. So this 207.5 is nothing but the total voltage drop in the series winding. That voltage you have to divide with your shunt field resistance. So you will get the shunt current, right? So shunt current is available. Then you can say your armature current is nothing but the shunt current plus load current. Load current is given 15 ampere. So 15 plus the shunt field current, you get the armature current. Then you multiply this armature current with your armature resistance. So armature current is you getting 17.075 and multiply with the 0.5 of your armature resistance, you will get this armature drop. So now you can say the terminal voltage 200 plus armature drop this much and plus your series drop this much 7.5 plus your brush drop 1. So you will get the total voltage of the generator voltage to 118.038 voltage, right? This is your required generator voltage, right? So generator voltage of this case we have calculated depending upon the given data 200 volt short shunt generator. Short shunt generator means this is where the shunt field of the compound generator connected in parallel to only to the armature. This diagram, right? And you can say armature current IA coming out of the armature is nothing but IA equal to ISH plus IL or ISC. That is same current. IL load current same as of that of the field current, series field current, right? So you have to consider the both the drop. That's why this equation is also considering V plus armature drop. Previous shunt case में only we consider V plus armature drop, but here series field resistance also there. So you have to consider that drop plus you have to consider the brush drop because brush drop also given. Brush drop also given in the numerical. It is given, we have to consider. It is not given, then there is no need to worry about, right? So accordingly, you need voltage drop. The terminal voltage of total voltage 200 given. Armature drop you have determined, for which you need armature current and RA. RA is given. So armature current we have determined. Armature current from the diagram IA equal to ISH plus IL. So ISH is not given, IL is given. So ISH is nothing but the total voltage available across this terminal. So that voltage has been taken. We have to calculate. For that purpose, first we should determine the voltage drop in the series winding. So series winding voltage drop, what is series winding voltage drop? Series winding voltage drop is nothing but this one. So current in the series winding multiply with your resistance of the series winding. So that way we determine series winding voltage in series winding IL into RAC. So IL into RAC 7.5 volt, right? That is 7.5 volt, right? And that is also we calculated here. And to determine the shunt current, we need the total voltage. So total voltage we have determined. This is the 200 voltage plus the drop in the series field winding. So that's why here we determine the total voltage across series winding is nothing but the 200 plus 7.5. So 207.5. So this 207.5 should be divided by your the shunt field resistance of the 100, so that you will get the shunt field current, right? So shunt field current we determine ISH equal to 207.5 divided by 100, so 2.075 ampere. So the armature current is nothing but what? From the diagram, IA is coming out of this armature. IA equal to ISH plus IL. So ISH we determine from here, and your IL already given 15 ampere. IL is already given 15 ampere already given. That's all. So you determine IA. So once you determine IA, voltage drop in armature, IA into RA. IA calculated and RA is already given 0.5 to that drop. So add the terminal voltage plus drop in your armature plus drop in your series winding plus drop brush drop. So you will get the total EMF generator. So this is about the another numerical, right? So this way we have discussed the 3 numerical in this session, right? So let us to come to end of the sessions. We may discuss with some other numerical on the DC motor in the next class. Thank you, dear students.